Alright, it's time for the next episode of Tube Time. I know this has been a bit of a long time coming. Anyway, the reason why I've put this off for so long is because, well, I had the problem with my computer sound. And also some of you might know that my microphone preamp, which I've got right here, this is the preamp that I used for my microphone that I made, has died. And this is the culprit. A dead 741 op amp. So for now I've just rigged up a temporary a temporary microphone preamp on the breadboard here. Just a simple single transistor preamp powered by my laptop's USB. This is the schematic for those of you interested. Because this setup right here, even though I'm using a homemade microphone and a homemade preamp, these two sound a hell of a lot better than the built-in microphone on my webcam. And also I was struck down by a bad cold the other day, delaying this video even further. But anyway, I'm pretty much over that now, so let's get on with today's episode of Tube Time. Welcome to Tube Time on Cool Dude Clem's Electronic Workshop. So, what are we going to do today? I thought we would build a rectifier circuit and then something to power off this rectifier. This is the valve or tube that we're going to use for the rectifying. Now, I know these are more suitable for high voltages. I mean, you can actually get x-rays off one of these. But we won't be getting any x-rays off that one with the voltages I'm going to be using it at. But first I thought we'd do a little bit of an interesting experiment. Let's see what the actual resistance of this valve is. Right, well, we're ready to test the resistance of this valve. Here's the setup in sort of semi-schematic form. So over here I've got the transformer that's going to power the filament. Here I've got a 40 volt supply. It's going to go into this ammeter, then into this 10k resistor, and into the valve. And as you can see, I've drawn it out so you can see pretty much what is inside this valve. We've got the anode on the outside there, then the cathode there, and inside the cathode there's the filament. And it's not really easy to tell, but one side of the filament is actually connected to the cathode, and I don't really like that, but there's nothing much I can do about that because it's wired that way inside the tube. Much prefer the filament to be completely isolated, but what are you going to do? So that's why I've got one side of the 3.7 volt AC filament voltage connected there as well. Anyway, whatever voltage we get across the tube multiplied by the current is going to give us the resistance. You know what I really like about these valves? These particular ones, you can actually see inside. It's a bit difficult to see in there. Now some of you might be wondering why there's a coil of wire around this transformer. Well, that's the secondary to power the filament of this valve. I don't have a transformer that will do the 3.7 volts that this filament needs. I mean, this one here is about 6.3 volts, so that's way too high. So I just wrapped a coil of wire around the core of the transformer. There wasn't enough gap to wrap the wire there, so I had to wrap it around the edge of the transformer. That's why it's like that, but it still works, and that's the point. So, turn the meters on. We've got this one to measure the voltage across the valve, this one measuring the current in milliamps. So I'll turn my power supply on. Of course, we're not going to see anything on the meters at the moment because, well, the filament isn't on, so the valve isn't going to conduct anything. Can you hear those weird noises outside? I don't know what the hell that is. So anyway, we've got about 40 volts going through this. And of course it's not going to work cold cathode, so plug in the transformer, this ancient transformer, to warm up the filament. And we should see some current flowing. Okay, yep, voltage is starting to rise. Okay, I've got the meter connected backwards, but that's not really going to be... It's not really going to matter. And we've got such little current flowing that it's not even registering on this meter. Okay, I'll be back. The connection between my meter and my power supply isn't very good. That's why we're getting weird results here, but now the filament's on, you can see, you might be able to see inside there a little bit better. The camera's still blurring out like mad, but I just noticed something interesting. This red wire is going to the meter, which is this red wire here is this point here on the circuit. And if I touch that, which I'll do right now, this valve is actually rectifying the voltage that my body's picking up. Thought that was rather interesting. Anyway, let's plug this into the 40 volts, or, well, it's actually more close to 45. Just put that in there. Okay, there we go. So now we can see what we got. Okay, so across this valve we have 28.9 volts. And the current is 1.8 milliamps. Damn, what the hell is that? Don't know if you can actually hear that. There's a whole lot of banging going on outside. I have no idea what that is. And now to work this out, we just need to use a little bit of Ohm's law. Just divide the voltage by the current. And in this case, because we're dividing the voltage by the milliamps, we'll get the answer in kiloohms. I'm too cheap to work it out in my head, so let's see. We've got 28.8 volts, or thereabouts. Divide by 1.8 milliamps. Should be showing it in the camera. This is a calculator where I reversed the LCD screen, so it's black on grey instead of grey on black. We have about 16, if you can see that. That's 16 kiloohms. I make that. That's quite high. I mean, that's quite high even for a tube. But the numbers don't lie. And just to prove that, I've replaced that valve with a variable resistor that I've set to 16K, 16 kiloohms, and as you can see, same results. About 1.8 milliamps there, about 28 volts there. And if you don't believe me about the variable resistor, well, let's measure that variable resistor. Okay. Since one end of this meter is already connected to that, we can just do that. And I'll just take this crocodile clip here, put this onto resistance. Hopefully you can see the screen. Let's put it onto 20K, that'll be much easier. Click this one on here to the other end, and as you can see, well, okay, it's drifted a little bit since I said it, but we've got 15.9, so that's pretty much close enough. Anyway, here's the circuit I'm going to make. Similar to what you saw before, we got the same 3.6, well, it was supposed to be 3.7, I made a little mistake there, but 3.7 volts powering the filament. Then we got the valve here, the anode connected to one side, the transformer, the anode going out to this capacitor here, and this choke and this other capacitor, which is known as a pi filter. We should get a pretty smooth DC out there. And of course, because we've got one side of the transformer, and so we don't get one side of the transformer's high voltage output floating, I've actually connected that to ground, to earth. So that will stay at 0 volts, and we'll get all the AC on that side, on that wire. Right, okay, we've got it all hooked up here. There's the complete half-wave rectifier circuit with our transformer, filter capacitor, choke, other filter capacitor, and of course, the all-important rectifier tube. Want to demonstrate it now? So let's put this in. I'm doing this with the lights off so we can see the nice glow from the tube. Alright, that's warming up now, and in a few seconds we should see the voltage start to climb. There we go. Here it goes, it's coming up. It's going to take a little while because this isn't exactly a low resistance tube, but we're already at over 130 volts. I actually do know what the voltage is of this because I ran this just now, earlier, last night. And I will say that this does get up to about 360 volts. So yes, wouldn't really want to touch the output. Good thing I've used 400 volt rated capacitors. Yeah, it's sort of petering out now. Cat's making a lot of noise. As you can see, we're over 310 volts. And the tube is glowing very merrily away. I don't know why my voice is going like this, but yeah. Well, I think the voltage is about as high as it's going to get. And there's absolutely no way I'm gonna touch any of this. This because that will be rather warm now, and I have been zapped by a capacitor that's been charged with over 300 volts before in the past, and I can tell you it stinks. Of course the voltage will drop a little bit once we put a load on this, but I think we've got a pretty good tube-based power supply. Anyway, we've got to find something to power up from that little power supply, so I've come up with, considering that my microphone preamp has died, I know I'm still using that one that I'm using on the breadboard, but my main microphone preamp has died. I've thought, what about I make another microphone preamp using valves, or in this case, one of these dual triodes. So this is the circuit we got. It's a two-stage amplifier. This side of the tube amplifies the microphone. Then this side of the tube amplifies what this side of the tube did. So we get like double the effect. And this probably won't work, but I'm going to try connecting both cathodes together and connecting them to the same resistor and capacitor. Like I said, I'm not sure if that's the best idea, but I'm going to try it and see if it works, and if it doesn't, well, just see what we do. I built it, and it's not working. I'm just temporarily powering it up on my variable power supply, giving it 45 volts. And it appears to be motorboating. I think this is about the first case where I've ever seen a valve circuit do that. Turn the light out. We might be able to see the protection LEDs to protect the amplifier pulsing. You can see the red one going. The green one not so much. If I turn the volume up, you can see the light flashes every time it makes that noise. Sounds like a heartbeat, doesn't it? The strange thing is, if I back the plate voltage off, I'm powering this on 45 volts right now. I'm going to put it down to about 18 volts. Okay, maybe just need to back that up more. At some point it actually stops doing that. But there, it does actually work like an amplifier now. I've got this little speaker that I'm using as a microphone. If I tap it, it is actually amplifying. Yeah, we still got some zany low frequency oscillation going on there. Anyway, I believe it's because of the way that I set up the bias on this. I didn't think it was going to work, but it was worth a try anyway, just to see what would happen. Okay, what I'm going to do is I'm just going to short out that capacitor so the cathode is right on the ground. I need to find a piece of wire I can use that I'm not going to... I don't have to get near the valve where I might burn myself on it. Of course, later on we will try it on this much more appropriate looking power supply. I don't know what the voltage will be when this is on it, but I'm sure we'll find out. I'm just going to short the cathode to the ground. I'm taking out this capacitor. There we go. Well, the speakers have stopped moving, that's one thing. Do we still have amplification though? I'm just going to touch the microphone here. Well, a little speaker thing. Okay, yeah, there we do. I have no idea what I'm feeding this at the moment. Probably about 15 volts. Well, let's ramp that up to 45. That's me touching this, by the way. Well, I can hear some hiss now. When I turned up the voltage. I'm going to talk into the microphone. It's working. Just pick up the little microphone here. Okay. This is not the best thing to use as a microphone, but I thought it would be good for a test. Okay, that seems to be working. I'll just put it back on there. Okay, so now we know what the problem is. Shagadagga wagadagga. Dude. I don't know why I just said that, but check it out. I've just gone and performed a crazy experiment here. I thought, what about I get a little Electret microphone insert, like this one I've got right here, and connect it straight up to the valve's filament, the valve's grid. And guess what? It actually works. So let's just take a little look at the changes that I made to the circuit. Well, this capacitor and this resistor are no longer in the circuit. I know the capacitor's still there on the valve, but that's shorted out, so it might just as well not even be there at all. So we have the cathode now connected straight to the ground, so you might just as well ignore those two parts because they're not in there. I just realised I'm not talking into the microphone that I have connected to my laptop. And this capacitor is no longer in the circuit. So we have a straight connection from the valve's grid to the little Electret microphone thing. The only thing that is a little bit of a problem is that I have to connect this in reverse because these things are actually polarized. And the thing is, because the valve is going to give out, normally it's going to give out about -1 volts or something like that. That's enough to provide phantom power for the little microphone insert. So I don't even need to come up with a separate circuit, and originally I was going to use an Electret microphone with this preamp, so that's kind of turned out really good. I think I was talking a little bit too loudly into the microphone there. Might have, on the laptop, it might have clipped. I decided that it would be a bit of a shame if I ended this video before trying to power this thing up on this power supply here, this valve power supply. So that's what I've gone and done. Now powering up this preamp from this valve power supply with a valve. Oh, look at that. My voltage detector pen is lit up. So anyway, I'm just going to take you through a little run through of the thing. It is working really, really well. I'm actually quite surprised at how well this works. So anyway, we got this ancient 1960s transformer providing not only the 3.3 volts for this valve's filament, it's also providing the 6. Okay, that's a bit weird. This should not light up at 6.3 volts. But anyway, like I was saying, so that 6.3 volts is going and powering the filaments on this valve, so they're being AC powered. And of course, this is providing the high voltage being rectified by this tube here, smoothed by this capacitor here, smoothed further by this inductor here, which is just a transformer that I've wired in series with the rest of it, and finally being smoothed by this capacitor here. Also, on the meters, I'm measuring the voltages at the various parts of the circuit. I know you can't see the meters very well. Unfortunately, I don't want to try and move them because, you know, I might short out a wire, and that would not be a very good end to this experiment, so you're just going to have to take my word on this. So we've got this meter here, measuring the voltage coming out of the power supply. Now remember, I did say that when I put a load on it, it's going to pull the voltage down a bit, so we've got 227 volts powering this. This one is measuring the plate voltage at one of the plates, and it is at the moment 28.8 volts. Not too bad. And I'm sure the other plate would be exactly the same, since they're both connected via 100k resistors. Anyway, I would say this is working really, really well. In fact, it's working better than I expected it to. Even though we've got one end of this transformer's high voltage winding, one end connected to the ground, that doesn't seem to be much of a problem. But I know what some of you are asking. Yeah, that might be all well and good, but how well does this sound? You've been rabbiting on, and we haven't heard a sound demonstration of this yet. Well, boys and girls, chaps and ladies, if there's any watching, this entire part of this video that you're watching right now, you have been listening directly off this valve and this little microphone. So anyway, I'm going to call that a success for now, and I'm going to try and decide where I'm going to take this next. So like I always say, until next time, goodbye. Hello and welcome to a new section of Cool Dude Clem's electronic workshop I'm going to call Tube Time. Welcome to Tube Time on Cool Dude Clem's electronic workshop. Okay, so I decided I'd revisit the one-tube regenerative radio, and this is what I've done. No, I'm not going to talk like that. I'm not going to talk like I used to in my old videos. I thought I would go back and revisit the one-tube regenerative radio and try to actually build a case for it and build a power supply for it. Well, unfortunately, this particular circuit I'm going to scrap because no matter what I do, it doesn't seem to want to work anymore. And I'm too much of a lazy sod to actually go find out what's wrong there and try to fix it. It's on right now, and all I'm getting, maybe you can hear that, is a buzz. That's it. Absolutely nothing else. Which is really disappointing because I came up with a pretty good way of tuning this thing. This is the coil right here, and got the ferrite rod on this little mechanism here that can be moved in and out, and that's the coarse tuning. That would have worked pretty well if this thing still works. Now I've got the variable capacitor down here for the fine tuning, but nothing. Absolutely nothing. Turn out the regeneration control, doesn't matter. All I'm hearing is a buzz. That may sound a bit weird to some of you living outside of England who live in 60 Hz regions. Well, here the AC sounds like that. So I'll just turn that off. So I'm scrapping the circuit, actually. Just gonna turn it off, let it cool down. I ain't touching that for a while. I don't actually know how hot those particular ones get, but not gonna take any chances. I mean, not gonna take any chances. Forget, I'm British, I'm supposed to say or instead of ah. Although I wish I was American because I hate England. Yes, I said it. And I got a really squeaky floorboard here. So I'm just scrapping this circuit. I didn't even get to the point where I was going to cut this out to the right size. You know, I was going to put a knob on the other end of this thing and, you know, put all the controls through the thing and make a nice looking radio, but that's not going to be, well, it's not going to use this circuit. Instead, I'm going to build another regenerative radio. My own design this time, using one of these. This is an RCA 6C6 from about 1943. It's pentode. Barely ever been used. So it's got plenty of life in it. And here's the circuit. And I wish I could get the camera closer because I've got it right pressed up against the thing right now, and this is as close as I can get it. And there's no zoom on my camera, so I'll have to zoom in post-editing. Pretty simple circuit. Here's the valve. Gonna power it on 45 volts. That should be plenty enough voltage. If not, I'll just make a higher voltage power supply. So that's not really gonna be much of a problem. Got a tuning coil and tuning capacitor here. Aerial, isolation capacitor, ground. And for the feedback, what I'm going to do, so feed the output signal into this capacitor here, and into this variable resistor here, which goes into this coil, and that's how the regenerative feedback is going to work. And of course, got to be careful not to turn it up too much, or it will start to transmit out of the aerial and interfere with every other radio that's trying to tune into the same frequency, so got to be careful with that. And these two components here are optional. I'm just going to add those in if the grid voltage is too low, like at 0 volts or something like that. I mean, if it's at -1 volts or more, it's going to be perfectly fine, but so I'm going to go build this circuit out. And yes, I already have some of the parts. We got the valve here, we got tuning coil here, which I wound onto the end of a fluorescent tube. I've actually got some paper on the end of there. Stuck the paper on the end of the fluorescent tube, but of course, when I wound the wire on there, now I cannot get that off without breaking something, and yeah. I'm basically just going to use this as my test coil. If that works, then I'll wind another coil. And here's the tuning capacitor. No idea how many picofarads this is, but I think that's going to work pretty good. Well, here it is, all built up and stuff, but it's not working. And no matter what I do, no matter what I try to tune into, no matter what I do, nothing. Absolutely nothing. No matter what I tune this into, no matter what I turn the regeneration control up to, Nothing whatsoever. I blame this coil. I had serious doubts that that was going to work anyway. It's not like this isn't doing anything. Far from it, actually. I don't even need to touch anything if I even just put my hand near it. I can hear a hum come out of the speakers. I don't know if you could hear that, probably couldn't. So no problem there. If I touch the anode, if I touch the first grid, which is what this bit here is connected to. I know on most of these, that's where the plate's connected, but on these particular ones, that's where the first grid is connected. Actually, if I touch this bit first, which goes into the amplifier, oh, if you could see what I was touching, this is the output capacitor. Might be able to hear something very slightly, but if I touch this, no problem there, we got plenty of amplification. Trying this with a different coil, and it's doing something. Or at least it was earlier. Now let's try to tune this thing into something. At the moment all I'm getting is a buzz, as you can probably hear. But it's definitely doing something. I'm using this coil here from that other project that I scrapped. The sort of tap that's sort of quarter of the way across the coil, I'm using that as the ground. So anyway, that might be a little bit hard to follow, so I've drawn up a schematic of what's actually going on, so it might be a bit easier to follow. So this is what I've done. Using the coil out of that other radio project that I scrapped, which is tapped about a quarter of the way across. And yes, this coil is wrapped around a ferrite bar, which is what I've drawn in there. And for the feedback part of the circuit, instead of using a variable resistor, I'm using a variable capacitor. And that seems to work quite well. I'm actually quite surprised that it'll work with a tapped coil. I thought we might get some phasing issues or something like that, but it seems to work absolutely fine. It's just not picking up any radio frequencies. Right about there, we got a lot of static. Okay, well, I've made another coil now. And this one has a separate tuning section and a separate feedback section. So ignore this coil here, that's now not doing anything at all, that's not even connected to the circuit. Got the feedback connected, like it was before, to the valve's output through this tuning capacitor. And what can I say, but it works. Or at least it was working a minute ago. I was picking up something, I think the tuning might have drifted. It's still picking up a ton of interference. There we are, we've got something. I think I'm just gonna use one gang of this tuning capacitor because tuning's very touchy. Could just do something about all that interference that it's receiving, you know, all that buzzing that it's receiving. It's I was picking up some incomprehensible babble. Let's adjust the regeneration. That's just about the 4 oscillation there. Is that Indian or Spanish or... Actually, what language is that? It's either French or Indian, I don't know which, they all sound the same to me. Yeah, don't get much on the other from here on though. Only right at the end of the dial. I'm sure once I put this in a nice sealed box though, sealed off from all the outside interference, that will sound a lot better. It won't have all that humming in the background.
Gestiegen. Zunächst der Index lag zum Schluss bei 4.507. Und ging mit 9.000.
Yeah, I think that's about all we're going to be able to get for now. Well, it's looking more like something now. I've made a box for it. Well, an enclosure for it. And yes, I've used cardboard because I'm a lazy bum and cardboard is easy to work with. But anyway, we've got the one tube or valve sticking out the front like that. Of course, I'm going to glue everything down properly after I test this. Let's just get that wire out of the way. And this is the inside of it. There's our tuning capacitor, there's our feedback capacitor, and of course the coil itself. Okay, so this rather odd looking contraption that you can see is the almost finished AM regenerative radio. I've put this metal shielding around the tube to try to cut out some of the interference, cut out some of the hum it's receiving, and hopefully that will cut out most of it. And let's just take a little look inside. It still looks a bit messy, but I've tidied up the wiring as best as I can, and I've also wired both gangs of this feedback capacitor in parallel to give it a bit more capacitance so I get more regeneration. And now let's give it a listen to see, or rather hear, how good it sounds. Right, so let's give this thing a listen. I'm gonna turn the power on because I've got it connected to my power supply. I'm gonna power this on about 30 volts. Okay, filament should be warming up. And in a minute we should get something, if it's even tuning. Okay, all we're getting is buzz. But there's a radio station coming in. Well, it's definitely picking up things. Despite the fact that we're getting some buzz. It's picking up something really strong about there. Let's try to adjust the regeneration. Well, I think I'm going to call that a success. Hang on, I'm going to have to turn the thing off so you can hear me over it. I'll turn the amplifier down. Yeah, I think I'm going to call that a bit of a success, actually. I don't know what it's actually picking up. I don't know what the frequency it's on or anything like that. So I don't know what station it is. Yeah, if I could just figure out what's causing that buzz, that hum, although it might be the fluorescent lights. Let me just adjust the lighting here. That was part of the reason. I've now got the low lights turned on, but you can still see what I'm doing. You can see the valve glowing a bit now.
I just wonder if the things that you're suggesting are actually going to stop him, or whether...
Okay, I'm going to increase the voltage to 40 volts.
A lot of what you're suggesting is it would be a bit of a bluff, because he knows that, when it comes to it, if you...
Of course, I am going to put this together properly.
Bit of hardware installed, and he'll just...
It's worth mentioning at the beginning of the show as well as at the end. It's no good giving the lady and the gentleman on the telephone messages to pass to me because they won't get passed.
Oh, there we go. We went into oscillation there. The only thing that's a little bit of a problem is that adjusting the regeneration does retune it a bit, but that can always happen. Let's see how far...
Der Instrumentalpart hingegen rasch.
No, don't go into oscillation.
Viele nennen die Spieler hier als Transportmedium in diesem neuen akustischen Raum.
Okay. Well, no good talking, lady. I don't understand French. There's something coming in really faint. If I could just pinpoint the point before an oscillation starts. That sounds like modern music to me, so I'm not gonna play that. Oh yuck, there it is again. Anyway, before I go, like I said, I promised I'd show a schematic of the thing, so here it is for all to see. This is the schematic of the radio that you just heard in the previous clip. Got the two coils here. We've got the main tuning coil, there's the feedback coil wound around a ferrite bar. The only thing I don't know is the values of the two tuning capacitors. Well, variable capacitors. So that's why I've marked them as question mark, because I have absolutely no idea what those are. And some of you might be wondering what these LEDs are for. Well, that's to limit the voltage that comes out of the radio, so in case we get a nasty high voltage spike when we turn the radio on or off, those LEDs will catch that, and because there's very little current, it's not going to blow them. So it'll limit the voltage to about 2 to 3 volts, whatever the LEDs work on. So not enough to blow the amplifier that I had this connected to. And that's basically it. So I'll see you next time, and like I always say, until next time, goodbye.